Hello, welcome back to my channel. In this lecture, we are going to discuss three important characteristics for DC shunt motors, and we will see what are the major applications for DC shunt motors. Okay, so let us start with the first characteristics, that is torque versus armature current characteristics. Here you can see the characteristics curve for DC shunt motors. We know that for DC motors, the torque equation T is equal to 0.159 Z IA into P by A, and here Z, P, A are constants. So torque is directly proportional to the flux and the armature current. So phi into IA. But we know that for DC shunt motors, the applied voltage is constant and also the field current and thereby the flux will be constant. So this equation will become torque is directly proportional to IA only because flux is constant here. So we can say that the torque is directly proportional to the armature current. So when the armature current increases, then the armature torque, TA is the armature torque. So the torque will also increases along with the rise in armature current. So the graph will be like a straight line. So torque armature current characteristics will be a straight line for DC shunt motors. Okay, you can remember this point. Now we are going to discuss about the second important characteristics for DC shunt motors, that is the relationship between the speed armature current characteristics. So, but we know that in the equation for DC motor, back EMF equation for DC motor will be EB is equal to 5ZNP divided by 60 into A, and here Z, P, A are the constant terms. So from here we can write the equation for speed, that is speed is directly proportional to the back EMF and inversely proportional to the flux. But already we discussed for DC shunt motors the flux will be constant. So we can write this relation between the speed and the back EMF like this. Speed is directly proportional to the back EMF. But we know that back EMF equation we can return for DC shunt motors, it is V minus IA into RA. So N is directly proportional to V minus IA RA. And remember that when we increase this armature current, then what will happen? This IA RA drop will increases. So EB will decreases because EB is clearly depends on this armature current. So when we increase this armature current, EB will decreases. And due to this reason, the flux will also decreases. So we can say that the relationship between the speed and armature current will be like this. That is, it will be like a dropping characteristics. When the load increases, back EMF will slightly decreases so that the speed slightly decreases from no load to full load. Means when the load increases, then armature current will increases. So the back EMF will decreases. Normally the drop will varies from 5 to 15% of full load. This straight line shows the curve for speed and armature current for full load. This for full load, and this dotted portions represents the relation between the speed and armature current at full load. Okay, so from no load to full load, the graph will be like slightly dropping, and that drop will varies from 5 to 50%. Okay, so this term is very important for DC shunt motors. Speed armature current characteristics, the graph will be like a slightly dropping. This term is very important for exams, technical exams. Okay. And the third important characteristics that will give you the relationship between the speed and the armature torque characteristics. This is the mechanical characteristics for DC shunt motors. First two characteristics are the electrical characteristics. And based on the electrical characteristics, we can easily explain the mechanical characteristics. So this will give you the relationship between the speed and armature torque. We know that the speed reduces when the load increases, just like slowly decreasing. And armature torque is directly proportional to the armature current. We have seen this point in the first graph. So the torque armature current graph will be like a straight line. And the shunt motor runs from no load to full load. There will be a slight change in its speed. So we can say that this will be the characteristics curve for DC shunt motor, when we need to show the relation between the speed and armature torque. Okay, so we can say that this DC shunt motors are normally a constant speed motor, because if we increase the load from no load to full load, there will be a slight change in its speed. So that we can say that the DC shunt motors are constant speed motors. So based on this, the applications of DC shunt motors are mainly it is used in lathe machines, drilling machines, boring mills, shapers, woodworking machines, weaving machines, etc. And wherever we need constant speed, there we can use this DC shunt motors. But if we need high starting torque, then we use DC series motors only. So these are the major points about the DC shunt motors. Okay, thank you.